Good day, students. Welcome to this JSS 1 Basic Science lesson on electricity, the basic concept. Electricity is the lifeblood of modern civilization and one of the most pressing challenges facing Nigeria. Understanding how electricity works, from the atomic level to household circuits, is both practical and intellectually fascinating. By the end of this lesson, you will be able to define electricity and explain electric charge, distinguish between static and current electricity, identify the components of a simple electric circuit and draw circuit diagrams, explain conductors and insulators, distinguish between series and parallel circuits, and apply basic electrical safety rules. Let us begin. What is electricity? Electricity is the flow of electric charges, usually electrons, through a conductor. Electric charge. All matter is made of atoms. Atoms contain protons, positive charge, in nucleus, neutrons, no charge, in nucleus, electrons, negative charge, orbiting nucleus. Like charges repel, unlike charges attract. An object becomes charged when it gains or loses electrons. Static electricity, electric charge that builds up on the surface of an object, does not flow. It accumulates when two objects are rubbed together, one gives electrons to the other. When enough charge builds up, it discharges, a spark. Examples: rubbing a balloon on your hair and sticking it to a wall, lightning, discharge between cloud and ground or cloud to cloud, the shock when you touch a metal doorknob after walking on a carpet. Current electricity, electric charge that flows continuously through a conductor or wire. This is the electricity that powers all devices. Measured in amperes, A, using an ammeter. Electric current, I flow of charge. I equals Q over T, charge/time. Unit, ampere, A. Voltage/potential difference, V, the push that drives the current, energy per unit charge. Unit, volt, V. Measured by voltmeter. In Nigeria, mains voltage equals 220 to 240 V, AC. Resistance, or opposition to flow of current. Unit, ohm symbol. Ohm's law, V equals IR. Electrical power, P, rate of energy transfer. P equals 4. Unit, watt, W. 1 kilowatt equals 1000 W. Electric circuit. An electric circuit is a closed path through which current can flow. It requires energy source, battery, generator, connecting wires, conductors, and a load, bulb, motor, appliance. Open circuit, the path is broken, no current flows. Switch is open. Closed circuit, a complete, unbroken path, current flows. Switch is closed. Circuit symbols, used in circuit diagrams. Cell, battery, or multiple cells, switch, open, switch, closed, bulb/lamp, cycle times, resistor, ammeter, A, voltmeter, V connected in parallel, V, wire, straight line. Conductors and insulators. Conductors allow electric current to flow freely, they have free electrons that can move. Examples: copper, most common wire material, aluminium, iron, steel, silver, gold, graphite, salt water, human body, wet materials. Insulators do not allow electric current to flow, electrons are tightly bound. Examples: rubber, plastic, glass, wood, dry, air, dry, ceramic, cotton, PVC. Insulators are used to coat wires to prevent accidental shocks and short circuits. Series circuit. All components connected in one loop/line. Current has only one path. Same current flows through all components, all share the current. Voltage is divided among components. If one component fails, e.g., one bulb blows, all components stop working. Example: old-style Christmas tree lights, simple switch controls all. Advantage: simple design. Disadvantage: failure of one stops all. Parallel circuit. Components connected in branches, each branch is an independent path for current. Voltage is the same across each branch. Current is divided among branches, total current equals sum of branch currents. If one branch fails, others continue to work. Example, household electrical wiring in Nigeria, all appliances connected in parallel to the mains, your television failing does not switch off your fan. This is why all outlets in a room provide 220 V. Advantage, independent operation, same voltage for all devices. Disadvantage, more wiring, if total current too high tripped fuse/breaker. Electrical safety. Never touch bare, uninsulated wires. Keep water away from electrical sockets, water conducts electricity. Never overload sockets, plugging too many appliances into one socket fire risk. Use correct fuse/circuit breaker ratings. Switch off appliances before fixing or cleaning them. Never fly kites near power lines. Report damaged wires or flickering lights to PHCN/AKED/ your electrical authority. Earthing/grounding, connecting the metal casing of appliances to earth, ground, so that if a fault makes the casing live, current flows safely to earth rather than through a person. 3 examination questions. Question 1. A circuit has a battery of 12 V and a resistor of 4 ohms. Calculate the current flowing. Ohm's law, V equals R, I equals V/R. I equals V/I equals 12 volts equals 3A. Question 2. State 2 differences between series and parallel circuits. A. In a series circuit, there is only one path for current. In a parallel circuit, there are multiple independent paths/branches. B. In a series circuit, if one component fails, all fail. In a parallel circuit, if one branch fails, the others continue to operate. Also, in series, voltage is divided. In parallel, all components receive the same full voltage. Question 3. Explain why household wiring in Nigeria uses parallel circuits rather than series circuits. In a parallel circuit, each appliance is connected independently to the supply. This means, A. Each appliance receives the same mains voltage, 220 V. All appliances operate at their rated voltage. B. If one appliance fails or is switched off, the others continue to work independently. You don't want your fan to stop because your television broke. C. Each appliance has its own switch, branch switch, for independent control. In a series circuit, all appliances would share the current, and thus share the voltage, meaning high-power appliances would receive less voltage, and switching off one would stop them all. 3 common mistakes. Mistake 1. Confusing voltage, current, and resistance. Voltage, V, is the push/pressure that drives current, measured in volts. Current, I, is the flow of charge, measured in amperes. Resistance, R, is what opposes flow, measured in ohms. The relationship is, voltage equals current times resistance, V equals IR. Higher resistance, less current for the same voltage. Mistake 2. Thinking static electricity and current electricity are the same. Static electricity is stationary, it builds up and stays on a surface until it discharges in a spark. Current electricity flows continuously. Lightning is a dramatic static discharge. The electricity in your phone charger is current electricity from the mains. Mistake 3. Drawing an open circuit and saying current flows. Current only flows in a closed, complete circuit. If the switch is open, or a wire is broken, or a component has failed, the circuit is broken and no current flows anywhere in the circuit, in a series circuit. Summary. Electricity, flow of electrons through a conductor. Static, charge builds up on surfaces, discharges as spark, lightning. Current, I continuous flow, unit equals ampere, source equals battery or generator. Voltage, V driving force, unit equals volt, Nigeria mains equals 220-240 V. Resistance, or opposition to flow, unit equals ohm. Ohm's law, V equals IR, power, P equals 4, unit equals watt. Conductors, copper, aluminium, iron, salt water. Insulators, rubber, plastic, glass, dry wood. Series circuit, one path, shared current, divided voltage, all fail together. Parallel circuit, multiple paths, same voltage, divided current, independent operation, used in houses. Safety, no water near electricity, no overloading, earthing, correct fuses. For homework, A. Draw a series circuit with 3 bulbs and a switch, then draw a parallel circuit with 2 bulbs. B. Calculate current when V equals 24 V, I equals 6 ohms. C. List 5 electrical safety rules to follow at home. Attempt a quiz on your LMS. Keep exploring the world around you. Visit Litech Academy at academy.litech.com.ng. Until next time.